Find all the real zeros, determine the multiplicity, and decide what happens to the graph at each zero. First of all, this is not completely factored because this right here can be factored more. This is really the same as x times x plus 1 times x minus 1. And then I have another x minus 1 at the end. And I can rewrite this as x times x plus 1 times x minus 1 squared. Now we'll make a little table. And we'll call this zeros. We can call this multiplicity. And we can call this cross or touch. We have three factors, 1, 2, 3. I have a 0 at 0. X plus 1 has to equal 0. I have a 0 at negative 1. And here, x minus 1 equals 0, which would make me have a 0 at positive 1. The multiplicity on this first 0, well, that's to the first power, so it's 1. The second one is also 1, but the third one has a multiplicity of 2. And then does it cross or touch? Well, if it's odd, it looks like a line, so we can go through the x-axis. This crosses, but the square looks like a parabola, so it touches. I like to say bounces, but everybody else says touches. It did not say to graph it, but let's look at what it's doing. We have our first 0, the most left 0 is at negative 1, and it should cross through the x-axis, and it goes through. Then we have 0 happens at 0. And that's going to do the same thing. It's just going to go through the x-axis, which it does. Here it crosses, here it crosses, and then the last 0, which is at 1, has a multiplicity of 2, so it should just touch and look like a parabola, which is what it does. Sketch the graph of a polynomial function. So by determining the end behavior of the function and by plotting the x-intercept and y-intercept, we begin to sketch the graph. Let's make a chart. This is my zeros, this is my multiplicity, and this is my cross-touch. This factors to x minus 1, x plus 2, x minus 2. My zeros are x equals 1, minus 2, and plus 2. And the multiplicity on all of them are 1, and they all cross. And our zeros are our x-intercepts. My y-intercept is equal to the constant, which is equal to 4. And then we can begin to sketch. Let's begin. First thing I want to do is my x-intercept. I have a 0 at 1. I have a 0 at negative 2, and I have a 0 at positive 2. I also know my y-intercept is at 4. Those are all the points I know right now. Now I have to figure out what my end behavior is because it makes a difference where I start. I look at just the leading term. And in our case here, our leading term is x to the third. It's positive. That means it's going to go up on the right. And because it's odd, it's going to go down on the left. Now I'm just going to connect the dots. It doesn't matter which side you start on. I'm going to start on the left. I'm going to come up here, and I'm going to hit that dot. I look at negative 2, and it crosses. And it's going to go up to that point. It's got to get up there because that's the next point on my graph. It doesn't have to be the maximum. It could go up higher. We don't know. We're just sketching. And then we know at some point it's got to go back to that point. And that is 1. And at 1, it also crosses. Again, it comes down to somewhere. And then at some point it's got to go up because it's got to hit the next dot. And then it hits that dot, and that's at 2. And again, it crosses. And it matches our end behavior. It looks kind of like that. I don't know how high up it goes. I don't know how low down it goes at these maximum and minimums, but I do know that it has that shape. There's the actual sketch, and we can see that the shape of that is very similar to what I got. We see from the graph that there are 2 turning points. It turns here and it turns here. A polynomial of degree n, our degree here is 3, has at most n minus 1 turning points. Since the degree is 3, it can't turn more than twice. It could only turn once, but it can't turn 4 times. That's what that says. If it has degree n, it has at most n minus 1 turning points. But as we saw before, x to the 4th, it still looked like x squared. It only had 1 turning point because it has at most 3 turning points, but it could have less. A turning point in which the graph changes from increasing to decreasing is a relative maximum, and a turning point which changes from decreasing to increasing is called a relative minimum. That's not too hard to understand if you look at a picture. If my turning point is increasing and then decreasing, it has to be a max. This is increasing and then it's decreasing. If it's decreasing and then increasing, here it's decreasing and then increasing, we can see that it's a minimum. Without the use of calculus or graphing utility, there is no way to determine the precise coordinates of the relative maximum or relative minimum. But they're relative because I know what's happening before and I know what's happening after. It's increasing then decreasing makes it a max, decreasing then increasing makes it a min. 4-step process for sketching the graph. Determine the end behavior, very important. Plot the y-intercept, very helpful. Completely factor to find all the real zeros and their multiplicities. We did that. 4, again, I don't know if it's necessary, except for you do need to sketch the graph. Use a 4-step process to sketch the graph of the following polynomial functions. First thing we're going to do is the end behavior. To do end behavior when you don't actually see it written out as a leading term, to get the leading term, which is all I really want, I don't worry about this and I don't worry about this. If I multiply all those together, I get negative 2 x squared times x. My leading term is negative 2x to the 3rd. So it's odd and negative. Looking at the right-hand side, if it was positive, it would go up. If it's negative, the right-hand side goes down. And the left-hand side does the opposite when it's odd. The left-hand side goes up. Second thing, to find our zeros, we can make our table. Here's my zeros. Here's my multiplicity. And does it cross or touch? I have 1 0 at negative 2. And the multiplicity is our exponent. That's 2. And since our exponent is 2, it's going to behave like a parabola. It can't cross the x-axis. It can only touch. We have one more 0 at x minus 1, or x equals positive 1. It's got a multiplicity of 1, and that means it can cross the x-axis. The last thing I have to do is sketch the graph. We know we have a 0 at negative 2, and we have a 0 at positive 1. The zeros and x-intercepts are the same. And then we have our y-intercept. How do we find our y-intercept? We set x equal to 0. It's negative 2 times 0 plus 2 squared times 0 minus 1. This is equal to positive 8. And we know our n behaviors up on the left and down on the right. This time we'll start on the right-hand side. So I start here. I know it's going down. I come to that point, which is my 0 at 1. I know my multiplicity is 1, which means it can cross through. And then we have to come down. We have to go to that point, which is my 0 at -2. And the multiplicity is 2, which means that when it gets down here, it's got to bounce off or just touch. And then it's going to come back up, and it's going to look something like this. I make a circle around there. That looks like a parabola because that has a squared. And this looks like a straight line because it's to the first power. Use the 4-step process to sketch the graph of the following polynomial function. First, we need our n behavior. And we know our leading term is even and positive. If it's even, it acts like a parabola. And if it's positive, it's up on the right. And if it's a parabola, it matches the same direction on the left. Step 2, I have to find my zeros. Now, this part is a little harder when it's not factored. The first thing I want to do is I want to factor out the greatest common factor. My greatest common factor is x squared. So I factor an x squared out, and I get f of x equals x squared times x squared minus 2x minus 3. If I factor, the first term is x squared, so it's x times x. And then 3 is only 1 and 3. And then I'm going to do outer is x and inner is 3x. And since I need it to be negative, this has got to be negative and this has got to be positive, which means I have now plus x minus 3x, which is minus 2x. And last times last is minus 3. This is completely factored. And since it's completely factored, I can now find my zeros. I have a degree of 4. I actually do have 4 zeros, even though it only looks like I have 3. Let's make our table. I have my zeros, my multiplicity, and cross touch. This has a 0 at 0. X minus 3 equals 0 means I have a 0 at positive 3. And x plus 1 equals 0 means I have a 0 at negative 1. Now let's do the multiplicities. For the 0 at 0, it has a multiplicity of 2. For the 0 at 3, it's got a multiplicity of 1, and this has got a multiplicity of 1, which means this just touches the x-axis and these both cross. Our n behavior is up, up. Let's start drawing. Let's find our y-intercept. Well, if x equals 0, then everything is 0. That means my y-intercept is 0. X is 0, y is 0. I have a 0 at 0, 0. I have a 0 at 3. And I have a 0 at negative 1. And my y-intercept is already right there at the origin. I know my n behaviors are up, up. I can start from either side. This time I'll start from the left. I know I'm going to come down and I have to get to that dot. That's the dot at negative 1. If I look up at my table, it crosses at negative 1. It's going to come down, but then real quick, it's got to come back up. At 0, can't cross there. I can only touch there. When I get there, I come back down. Then I go back up. Again, I don't know how low to go. And then my last one is at 3, which means it crosses. And there's the sketch of the graph. Here's what it actually looks like. They're very similar. They're giving us a graph, and they're asking us some questions about it. Given that we have a graph, is the degree of the polynomial function even or odd? Well, the n behaviors tell me if it's even or odd. And because the ends are going in opposite directions, it means it is odd. If it was even, they would be going in the same direction. Is the leading coefficient positive or negative? Well, if it was positive, it should be going up on the right, but since it's going down on the right, we know it's got to be negative. What is the value of the constant coefficient? The constant is when x equals 0. If we have x cubed plus 2x squared plus 3x plus 5, well, when x equals 0, all of these go to 0, and I just get this. When x equals 0 is the y-intercept. My y-intercept is 2, so the value of the constant coefficient is 2. Identify the real zeros and state the multiplicity of each. I look at where it crosses the x-axis. I can make my table. All they're asking for is the 0 and the multiplicity. I'm starting here on the left. I have a 0 at -4. I don't really know exactly what my multiplicity is, but since it crosses, I know it's odd. Then I have a 0 here at -2. And at -2, it crosses, so it's also odd. I have a 0 at 1. I know this has got to be even. And lastly, I have a 0 at 4, and that crosses, so I know it's odd. The first one is at -5, not -4. Now, what are my possible functions? Well, I know that the only one that can be even is the 0 at 1, which would look like x minus 1. X minus 1 has to be even, so it can be that one. It cannot be this one because here it's odd. Everything else is odd. The only thing that's changing now is the leading coefficient. I want to pick a point where it's not one of the zeros, and I can use the 0, 2 point. They all have x plus 5 times x plus 2 times x minus 1 squared times x minus 4. If I pick that point 0, 2, that means that y is 2 and all the x's are 0. So I have 5 times 2 times -1 squared times -4, because all the x's are 0. What we're trying to find is a. 2 equals a times 5 times 2 is 10, minus 1 squared is 1, so 10 times 1 is 1, and 10 times -4 is -40. I divide both sides by -40. I get 2 divided by -40 is equal to a, is equal to a. If I simplify, a equals -1/20. The answer is the first one.